Hi everyone, Professor Bob Young back at you here. In this instructional video, we're going to continue our special factoring here, but in this case, we're going to concentrate on factoring what's called the sum and difference of two perfect cubes. Not squares anymore, ladies and gentlemen, but cubes. So where do perfect cubes come from? Now notice in the left column I talked about perfect cube numbers, and those come from just numbers cubed. So what I did is I said 1 cubed is 1 times 1 times 1, remember 1. 2 cubed, 2 times 2 times 2, 8. 3 cubed, 27. 4 cubed, 64. So we can cube numbers forever and ever and ever and come up with what's called perfect cube numbers in that right column. So take any number you can think of, cube it, you've got a perfect cube number, ladies and gentlemen. Now, where do perfect cube variables come from? If you remember in previous lessons when we factored squares, we said that if you had a perfect square variable, it was always divisible by 2. Guess what here? If you have a perfect cube variable, it's divisible by 3. And really, remember, variables are just numbers in disguise. So if we took, let's say, this first example here, x, and we just cubed it, do you see we would have x cubed? So really, if you just cube anything, you'll get something that's called a perfect cube. Now, what cubed would give me y to the 6th power? See, so if you can take something and cube it, it's a perfect cube. So in this case, if you know your power rules, ladies and gentlemen, it's y to the what power? Squared. Because whenever you raise a power to a power, you multiply it. And also you can think of it this way: if I took y squared times y squared 3 times, that would also give me y to the 6 using a different power rule. So how important are those power rules? So anything you can cube. Now notice when this happens, all the variables are divisible by 3. So it's very easy to recognize perfect cube variables and numbers once you get the hang of it. It's time for the perfect cube formulas now, ladies and gentlemen. Now, students are always asking me on this factoring test, can I use note cards? Can I use a handout? Can we use open books? No. Your college algebra professors and the higher level professors are going to expect you to know some of this when you get to the big league math courses. So what we're going to do is we're not going to try to memorize these formulas, but we're going to try to see how they work. Now, first, I'm going to start out with what's called a cubed plus b cubed. And notice I've gotten up here in the notes that whenever you factor the sum and difference of perfect cubes, they factor into a binomial times a trinomial. So I'm going to go ahead and put a binomial and then a little bit bigger parentheses here for a trinomial. Okay, and I'm also going to come down here and I'm going to put a cubed minus b cubed. So we're going to look at both the formulas for factoring the sum and difference of two cubes. And if you get this, you can factor any cubes, and we'll do that as we progress here. Now, when you start out with a cubed plus b cubed up top, here's what happens. The binomial part is a plus b. Now, think about what you need over here. What times a will give me a cube back over here? Let's ask ourselves that. Well, you'd probably say, well, Young, I need an a squared times an a to get an a cubed. And with similar thinking here, and I'll use a different color here. You know I love my colors. We're going to say b times what over here would give us b cubed. And again, we'd say, well, we need a b squared in here, Young. All right, so don't memorize things. Try to see how things work. Now, the only thing you have to know is this middle part here, which we're going to go green on. We're going to go green here. So what happens is what some mathematician did when he was like in chapter 5 when we were multiplying polynomials, binomials times trinomials and so forth, they found that this always worked with cubes. You would get a minus a times b in the middle there. and that would be a plus b cubed. So you'd have to be a plus b squared, because plus b squared times a plus b would give you a plus b cubed there. I have to go back to that. But the only thing you have to really remember here, if you remember how things kind of work, is that minus ab in the middle. All right, now let's try this again with the difference of cubes. Now up top here, it started out a plus b when you had the sum of two cubes. Guess what? Down here it starts out, would you guess, a minus b. So it's kind of like it looks starting out. Now again, you're going to need an a squared, and you're going to need a plus b squared. So there's something else in common here, the a squared and the plus. Now why is that a plus b squared? That's a minus on the bottom, Young. Well, remember, you've got a minus b in front here, times a plus b squared would give you the minus b cubed here. So do you see the similarities here? They start out, the binomial parts, looking like the cubes themselves, and then you got the a squared and the plus b squared. Now the only thing is, we're going back to the green now. Guess what kind of AB goes in here is the last piece of this puzzle, and that would be a plus AB. So if it's minus, the middle is plus. If it's plus, the middle is minus. So you just have to get familiar with this. Now I know some of you are thinking, I'll never remember all that and stuff, but you'd be surprised you will, and you just have to practice to get good at it. Now, if on a test you have time, I mean, if you're not sure that's the formula or something, you could actually take and multiply these out. You could say, if I want to take this A here, let's say I'm not sure of the sum of two cubes formula. You could take that A and you can distribute it through here. Like when you're multiplying binomials times trinomials in the previous sections. Then you can take that B, plus B in this case, multiply it through, and I'll bet anybody here, lunch, $100, quarter, whatever, that everything will go out except those two little a cubed plus b cubes when you collect like terms and distribute and all that good stuff. Anyone want to bet lunch, $100, quarter? No? Okay. Well, just learn those formulas then. They will check by multiplying. All factoring checks by multiplying, if you remember. All right, so here we go. We're going to do some now. You ready? Let's factor some cubes. So here's what they'll look like in the homework and on the test and on the practice test. You will have one of these, at least one on the test and practice test, and maybe even the exam. All right, x cubed plus 27. All right, now when I look at that, what I'm going to do is come over here and say, well, I'm going to remember that a cubed plus b cubed formula we just had there, and I'm going to write my binomial times my trinomial here. So I'm just going to remember the basic thing there, and I'm going to say, let's see if y'all remember now. You can't peek back on, well, you can peek back on the videos. That's beauty. You could rewind me. Starts out a plus b. You got an a squared in there, and you got a plus b squared here. So we'll get these formulas. The more you even look at it here, the more you'll remember them. What goes in the middle? What goes in the middle? Plus ab or minus ab? Minus a times b. And again, you could multiply that and check it. So how does this help me when I'm factoring the cube formulas, Young? Well, what I'm going to do is I'm going to, right under the a cubed and a plus b cubed, I'm going to put little cubey things under here. And then I'm going to come over here and I'm going to look at this and say, what do I put in here? What would I have to raise to the third power to get x cubed? And I don't think it'll take Einstein there. Most of you better come up with x. All right. Then what do I need to put in here to come up with 27? What cubed? And you will come up with 3. All right. Now, what did that do for me, Young? So what I call these are the cubic components. I'm going to just call that CC, cubic components. Because now, ladies and gentlemen, wherever I see an A, guess what? I'm just going to plug in an X in this formula. Wherever I see a B, you guessed it, I'm going to plug in 3, and we will show you how easy it is to factor cubes. So you ready? A is X plus B is 3. All right. A squared is X squared minus a times b. Now, we could put x3 there, but it doesn't sound good, see, because remember, a is x and b is 3 when you multiply them. But, you know, they're not going to write x3. They're going to write minus, so we'll write it 3x. And here's where you got to be really careful. When you put 3 in here for b, it gets squared. So remember, that's b squared, so that will be plus 9. All right? So ladies and gentlemen, you have just factored your first perfect cube, or maybe you factored them before, but x cubed plus 27 will factor into x plus 3 times x squared minus 3x plus 9. And there it is. Now you can multiply that and check it, and it will check by multiplication. You'll get the x cubed plus 27 back. All right, let's try the second example here. We've got 8x cubed minus 125. Young's making them harder here in the next few. So what I would do if I were you, let's come over here immediately and say, well, what's that minus formula for cube, Young? What's a cubed minus b cubed break apart into? Well, again, a binomial times a trinomial, so it's going to be a minus b starting out. If you remember, the binomial part looks the same. The trinomial has the a square plus b square. Now, Young, what goes in the middle? What goes in the middle? What kind of AB? Plus or minus? Well, this one, if you remember, drum roll, plus AB. All right, so far so good. I hope so. Now we're going to come down here and write this as cubic components again. So I'm going to go CC. Break these cubes down. Now, what times what in this first parentheses here will give me 8x cubed. Now, a lot of students in my lecture classes will go 2, 2, and they'll be right, but they forget something. Don't forget the variable. 2x has to go in there. Do you see that? 2x times 2x times 2x gives you 8x cubed. Number, what times what in the second parentheses? The cubic components. Try to say that fast, roll 5 times real fast. Cubic components. Cubic components. Cubic components. You'll be slurring on your computer screen there. All right. It would be minus 5. 5 cubed is 125. So you know what we're going to do now, ladies and gentlemen? Wherever we see an A in this formula, we're plugging in 2x. Wherever we see a B, you guessed it, 5. Are y'all ready? Here we go. Hold on. It's going to be a wild ride. So A minus B, 2x minus 5. Now here's where you got to be careful again. A squared, and I'm going to write it out this time. Wherever we see an A, remember, we're putting 2s, because students miss this. They don't like to show their steps. And it's real easy to show your steps because you know what you're plugging in for A, B, and C. And I'm just going to go ahead here, 2x and 5. And then I'm putting in 5 for B down here. Okay, 5 squared. So all I did again, wherever I saw an A, 2x, wherever I saw a B, 5. Now, ladies and gentlemen, let me warn you of one more thing here. Never, ever change the signs in here. Never change them. Because a lot of students will see this minus in front of here in blue. Let me bring it out here. And they'll go, that's a minus 5. That's a minus 5. No, A is 2x. B is 5. All right, the minus is part of the formula there. So if you change those signs, your grade will get changed. So be careful. Never, even up top here, never mess with any of these or your grade gets messed with, I'm sorry to say. All right, final answer. Here we go. 2x minus 5 times, if you take 2x and square it here, 2 times 2 would be 4x squared plus 10x would be 2x times 5 plus 25. And here is your factored answer. So 8x cubed minus 125 factors into 2x minus 5 times 4x squared plus 10x plus 25. Don't believe me? Multiply it back together. Take this 2x, run it through there. Take this 5, run it through there. Everything will go out except the 8x cubed and the minus 125. All right, let's do a couple more and we'll wrap this video up. I hope you're getting it here. You may even want to pause and do some of these on your own here. So I took x to the 6th power, oh Young, not a higher power x, plus 1, and I'm going to factor the cubes here. Okay, you ready for this? Here we go. So again, I'm going to write, well, this would be the plus formula, a cubed plus b cubed. Don't worry, you'll get lots of chance to practice on your homework too here. Starts out binomial, a plus b. You need the a square plus the b square in the trinomial part. And then I hope you remember the minus ab goes in the middle. All right, let's take it down here and go with the cubic components. You can take a little red pen and do this yourself if you want to. Okay, first cubic component. What times what times what gives me x to the 6th power? Or if I cube something, what gives me x to the 6th power? It was earlier in the video. I don't know if y'all remember, but it would be x squared. Cubed would be x to the 6th. No one better miss this last one. Remember, that's power rule number 5. Whenever you raise a power to a power, multiply the powers. If you miss that, it's all over. All right, and then it won't check either when you go to check it. So you can always check these if you try to go the wrong way and you don't get the right cubic component. Don't panic. 1 times 1 times 1 is 1. So 1 cubed is 1. So you know what? Wherever we see an A, x squared. Wherever we see a B, 1. And we'll get really good at these really quick here. So here we go. A plus B, x squared plus 1. Show your steps here. Don't get in a hurry. A squared would be, oh, be careful here, x squared squared. Because A, remember, wherever we see an A, we're putting in x squared. Minus AB, x squared times 1, plus B squared, don't mess with those signs, 1 squared. These are fun, huh? All right, so this final one would factor into x squared plus 1 on this graphic. X squared squared would be x to the 4th power minus x squared plus 1. So that is what this would factor into cube-wise. Now here comes the grand finale. Are you ready? This one might make you shake in your shoes and go, Mama, Mama! Here it is, the grand finale. I took a quantity cubed. Minus 64 here. You could even take perfect cube quantities, ladies and gentlemen, so I left lots of room on this one. But don't panic. It works the same way. Just come over here and go, all right, that is the a cubed minus b cubed formula. And we'll write our binomial times our trinomial. A minus b. We need the a square. We need the plus b square. What goes in the middle? What goes in the middle? Plus ab. So don't panic. All right, it's cubic component time. Now I'm going to spread this one out a little bit here because we might have to spread this one out a little bit. Okay. Give myself a little room here. All right. Now no one better miss this first one. What raised to the 3rd power gives me 2x minus 5 quantity to the 3rd power? Well, it's just kind of like it looks there. Silly gooses, 2x minus 5. What raised to the 3rd power gives me 64? I just had to pick a different number here. And I believe that would be 4 cubed. Okay, so wherever we see an A, we're going to plug in 2x minus 5. So you can even plug in more than one thing on these cube formulas. Wherever we see a B, 4. And are we going to mess with the signs? No. All right, so I'm going to come down here below this. And we're going to do it. All right, A minus B would be, all right, 2x minus 5. Now, I might want to use brackets here on this. Whenever I use parentheses, I like to use brackets, so it kind of differentiates the parentheses there. Minus B is minus 4. So do you see, that's the binomial part of this thing. Here's A, here's B. If you know the basic formulas, you're going to know them all. All right, here comes the other one. A squared is 2x minus 5 squared. All right, that's A. Plus A times B would be, well, it'd be 2x minus 5 times 4. And then plus B squared would be plus 4 squared. So it works the same way. Now, on this one, notice we've got some more fun to do here. We're going to come down here and say, and we'll take the green here, this will be removing the parentheses and so forth in there, if it's all right with y'all. So we're going to say, well, that's 2x minus 5 minus 4 in the parentheses. And then let's use the other colors here, purple. Guess what I have to do here, ladies and gentlemen? 2x minus 5 squared. It's a little FOIL problem. Oh, these are just good, these ones with quantities here. We have to FOIL that in the second parentheses, and we're going to have to collect like terms and stuff too. So I'm going to FOIL that, and I'm going to do it here in purple. So that would be 4x squared, so I'm just FOILing this, minus 10x minus 20x plus 25. Okay. Now I'm going to go green here. Now I have to take this and multiply or distribute this 4 through, and I'm going to get plus 8x minus 20. Isn't this fun kind of doing it this way? I like the colors. Sometimes the colors are just so fun. And then the 4 squared in orange will be plus 16. So you'll have a lot of good algebra in here. Now I think we're almost ready to put all this together here now. So I'm going to take the red back out, collect some like terms here. I'm going to start underlining some like terms. I see like terms in this second parentheses. I see some numbers we can put together. So ladies and gentlemen, when we factor this final creature, y'all ready? Here comes the answer, even with quantities. 2x minus 9, minus 5 minus 4, times 4x squared minus 12x minus 20 plus 8. Now y'all watch me here. Minus 12x, and then 25 minus 20 is 5 plus 16 is plus 21. Whew. So that is like one of the toughest ones. But if you can factor that, let's face it, you can factor anything. Now go practice some, practice, and then we will be up for a grand finale of factoring here soon. Bob Young signing off.